Previously, we defined equilibrium using two different but equivalent definitions. Specifically, we showed that a system achieves equilibrium when it maximizes its entropy and it minimizes its energy. Now, the properties of a system at equilibrium are going to depend on, its different characteristics, like its entropy, its internal energy, pressure, temperature, volume, different things like that. So we'll say that the properties of a system at equilibrium are defined by what are known as state variables, by its state variables. And so some examples of this would include entropy, internal energy, pressure, temperature, volume, number of molecules, and other sorts of things. Okay? Now, for a given, let's say, temperature, a system will have, will achieve some sort of equilibrium. But if that temperature is changed, then the equilibrium properties of a system will also change, and the system will evolve towards that new equilibrium state. We define the pathway in which a system takes to go between different equilibrium states. We're going to define that as a process. So a process describes the path of a system going between equilibrium states. Not only is it important to understand the equilibrium states of a system, it's also important to understand the process it takes in order to go between those equilibrium states, right? Because that process, in order to go from one temperature to another, that's going to involve potentially the addition or subtraction of heat from a system, or the addition or subtraction of work to a system. It's going to involve some sort of energy transfer. Now, in order to develop a framework for understanding and describing, processes, we're going to use the first and second law of thermodynamics. So the first and second laws of thermodynamics, what they do is they provide us a way to describe how internal energy and entropy change during a process. Change during process. All right? And so the goal of this module is to understand and go over how to apply these conservation laws in order to understand how a system behaves during a process. So in this module, we will apply these conservation laws to investigate how systems behave during a process.